And some of you kind of signed on just a little bit after I was here, and you missed the initial conversation. And what I was updating a few of the guys that were here early is that today is the day that we finish the book. We're going to finish 10.4 and 10.5, and that's it. I'm not going to really introduce any more new material. There is a chapter C on these things called conics, but with conics, they're not a high priority. Well, they're a high priority, but when you go to Calculus 2, even if you learn them now, you will forget everything, and your teacher in Calculus 2 will pretty much review all the conics with you at that time. Sometimes when you go to pre-calculus, that's the next semester course, some of the teachers will study conics. And when they study them, they will show them to you as if they're new, like you've never seen them before. So we're going to be plenty safe not studying those. And under the circumstances of the semester that we've had, I think there's no point in really kind of overdoing it. That'll make our last week of class kind of a time to kind of slow down and digest everything. So next week, you're going to have a test on chapters 9 and 10, and we're going to review for the final. So that's our whole week right there. Well, we'll review for the chapter 9 and 10 test on Monday. So next week is reviewing and the chapter 9-10 test. And then the week after that will be the final. All right, so let's finish this guy off then. Here's our goal. Both 10.4 and 10.5 are solving. We're going to solve equations. But we're going to solve a special kind of equation. We're going to solve a rational equation. So it's an equation with fractions. And we're going to learn two strategies. One way we're going to learn how to do it is by graphing. Now, technically, you can already do this because you guys have already learned the graphing strategy. You type in the left side, you type in the right side, and you find the intersection. So the pictures are going to look a little different because they're rational equations, but you already know how to solve these by the graphing calculator. What's the downside of the calculator? Is the answers are typically approximates. They're round-offs. We do not get exact answers. Sometimes we do, but for the most part, if you're doing the graphing calculator approach, you can't expect to have an exact answer. With the algebra method that we'll learn today, that will be new. It'll be a new way of thinking here. These answers are going to give us exact values. And that has advantages in many situations. So, but that's our game plan, is these two ideas right here. So let's turn in your book. I want you to go to page 410, number 22. And, oh no, pause, stop, stop the show. I forgot something important. My apologies. I don't know why it just came to me, but we didn't properly finish these problems. Christy was talking about it, and I was thinking, oh, good, I'm glad she's talking about it, and I never addressed it. Sorry.
The domain.
Yes, exactly. Yeah, good job. Charles, you're with me there. Problem number 16 on page 407. We were supposed to perform the operation. The operation is another way of saying add or subtract or multiply or divide. Okay, so we did that. When we subtracted this, we got the answer right here. This is the operation. This is the answer. To the subtraction problem. We're all done with the subtraction. But there was another question. Determining the domain. And the domain is the good x's. What are the good x's? What are the bad x's? This is a pretty nasty fraction. And you can't plug anything in there. Like your car, I've used this silly illustration many times now. You just can't put milk in the gas tank. It will cause your car to malfunction. You just can't put any number in here because it will cause this fraction to malfunction. And the bad numbers start from the very original problem. Now, what are the bad numbers? Sometimes they're easy enough that you can tell just by looking at them. What are the bad numbers for this first fraction?
We would have to set it to equal or not equal 0, right?
Exactly. Now, you can set it not equal to 0 and solve it. Or sometimes you can do it intuitively. The denominator cannot be 0. What's the bad number that I should plug in there that would make it bad?
-5.
Right. Okay, so if you can do that intuitively and you see, oh, -5 plus 5 is 0 on the bottom. 0 on the bottom is bad. You're done. What about the other fraction? What is the bad number for the other fraction?
0.
Right. So this is the domain. So sometimes you can just do it by inspection. If you look at the fractions, they're simple enough that you can just call them out right at the beginning. Okay, so now we're finally finished that problem. We did the subtraction answer and we figured out the domain. Let's practice the...
Why would you...
Say that again, Rihanna? Rihanna, you're cutting out, and I'm not hearing your entire comment or question.
Okay, I don't understand how you got the domain because I understand that it cannot equal 0. So I don't understand where your starting point in, like, where your logic is of finding those domains.
Yeah. So, to be honest, I did it as a shortcut here. I'm looking at this fraction and trying to find the bad numbers and throw them out. And that implies that all the other numbers are good. But let's go through the logic of it more formally. So I want to slow down and not do it by intuition, but like the whole logic. So this is a fraction. And there's a principle about fractions that if you have a number divided by 0, that's going to equal, well, it's not going to equal anything. It's going to be an error. It's impossible to divide by 0. And so we've established kind of a principle here. The bottom can't be 0. So what we do, if we want to find the errors, is we take the bottom and we set it not equal to 0. The bottom will be bad if the bottom equals 0. So if x plus 5 equals 0, that's going to be bad. We don't want this. And then we just solve it.
Okay, so I see why you got the -5.
Yes. And so some problems, for not everybody can do this in their head. And so if it doesn't make sense to you, go ahead and solve it out step by step.
Okay, no, I understand how you got. Now I see. I just didn't understand the logic behind it. Like I didn't. First, it was. I missed it.
Okay, no, great. So once you see that logic, I don't mind if you skip this and go right to the domain. But some problems are harder, and you can't do this mentally. You have to do it with the logic all the way out if they're harder. Like problem C. Some people might be able to do that with intuition and just, I know. Other people may have to work the logic all the way through. Jumping down to problem C. What is the domain restrictions?
It's -2.
-5
Okay,
and -2.
this one,
And 2.
yeah, that one's a real easy one. +2 is bad because 2 minus 2 will make 0 underneath. So that one, some of you could probably call that one out pretty quick. Now this one's not as obvious. Charles was thinking that it was -5. And so that may not be obvious to everybody. And if it's not, then you got to do the logic. X over 3x plus 5. This will be bad if the bottom equals 0. So the bottom cannot be 0.
It's 15, not 5.
Thank you. So I want to solve this, but I want to solve it for what I do not want. I don't want it to be 0. And then we just do the algebra here step by step. So this is the logic all the way through. Cannot be equal to -15. Divide by 3. So x cannot be 15. -15 divided by 3 is -5. So -5, sure enough, is the bad x. So there's the domain of that one.
So basically, we're setting the denominators to 0 to find what x cannot equal.
Exactly. Solve the bottom for 0, and those are the bad x's, and you're going to throw out those bad x's. So if it's kind of harder, you may have to actually do the algebra solving to figure them out. But if they're kind of easy, like 2x or x minus 2, you can just figure it out in your head intuitively. All right, so I don't know why that came to me in the middle of 10.4, but I'm glad I did review that with you. Okay, so 10.4, we're going to solve equations now. And you guys are going to turn with me to page 222. And when we come back from a break, we're going to solve this. All right, it is 1:32. I do want to kind of push this and not delay here because I'd like to get all the 10.4 and 10.5 done today. So I'm going to jump right in and keep going. So 10.4, we're going to solve the rational equations, but we're going to start off by doing them with graphs. And you guys may recall, I hope that you already know how to do that, where you take y1 to be one side, y2 to be the other side. So you split the equation in two parts, you make a graph of each one, and you look to see where they intersect. So like this one here, y1 equals 5x. Now 5x happens to be a linear function. So that one makes this graph right here the linear graph. But the other side is a fraction, 3 over x minus 4 plus 4. So the other side is a rational function. And what is the domain of the right side here? What is the bad x?
Four.
Right. So at 4, the graph is broken. And actually that shows up here at this, it's broken right here. 1, 2, 3, 4. It's hard to see, but we have an asymptote at 4. And the rest of the graph comes in with 2 branches on either side of 4. And once that happens, then we look and see, oh, there's 2 answers, because these 2 equations, these 2 graphs intersect twice. And then we use the intersection command and we can find them, and that's what they did down here. So let's try our own graph. Now really the only challenge to these is finding the window. That's the only hard part. You have to play around with the window numbers. And so you guys grab your calculators, and together let's do number 22. So your first step, what's the first step? Think about, how do you solve by graphing? Remind me, I'm particular. I want to see steps. Do you remember what the first step is?
Are you talking about plugging those in for y1 and y2?
Yes, but more than just plugging them, writing them down for me on a piece of paper. So if you're turning in your work and you're showing me your work, I want you to write them down so I see what you're making.
Okay.
Right? That looks familiar. We've done that before. And then the second step is the actual sketch. You're going to sketch it. It doesn't have to be perfect, beautiful sketch. It just has to show the rough idea, the window parameters, and the intersection point. Are you guys graphing it? I'd like you to be graphing it so that you're getting an outcome that you can compare your outcome with mine. All right, are you guys ready to compare graphs? Here's my graphing calculator. I got the left side 3, and I got 1 plus 3x divided by x minus 1. I hit the graph button. I'm using the standard window, and I get this picture. How many of you got that picture? Okay, got one.
Wow.
Now, something should be wrong with this picture, because if we graph this, does this have a domain restriction?
No.
Yes. It's 1.
Right here. X cannot be 1. The graph should be broken. We should see a broken place at 1. I don't see anything broken here. When you have a rational function, you should see 2 branches like this blue one, or 3 branches sometimes. So if you don't see branches, you know something's wrong. And so my graph is messed up here. Let's go back to the button y equals. What could be wrong with this?
There needs to be parentheses for the x minus 1.
Exactly. When you have
Oh, I put
fractions,
parentheses around the whole 3x divided by x1 minus 1.
yeah, so when we have fractions, it's the top that has parentheses. The top is a group and the bottom is a group. It's not the whole thing. It's the top and bottom we have to group. Now 3x is a multiplication. It doesn't have adding. That's not going to be a problem. But the x minus 1, what I graphed here was this. This is what the calculator sees. It sees 1 plus 3x over x minus 1. That's what the calculator is seeing. It's going left to right and doing the order of operations. 1, then it's taking 3x divided by x, and then after that it's doing 1 because it did the order of operations. And the division is before the subtraction, and this is not my equation. The only way to get my equation is to do the group first, x minus 1 first, and that means I need parentheses on the bottom, x minus 1. Whenever you have fractions, you should type in a lot of parentheses. Parentheses for the top of the fraction and parentheses for the bottom of the fraction. And when I graph now I'm seeing 2 different branches. Okay, so I think getting closer to being able to solve this. Now I want to find how many answers are there? Only 1. Yep, the intersection only crosses 1 time right here. So I got to find that answer. I'm going to go to second trace button, which opens up the calc menu. And since I have 2 sides, left and right, I want to intersect the 2 sides. So I'm going down here to number 5. And now I've got these questions. First curve, second curve, guess. First curve, enter. Second curve, enter. Guess, enter. And it found it at -2, 3. Okay, so let's translate that into our sketch. I'd kind of like to know, what is your window, so that I can kind of understand the dimensions of your picture. It helps me understand it. We have y equals 3, that's horizontal. And then right here we have intersection, -2, 3. I have a branch coming down and another branch going up. And that's a rough sketch of the work that you did in the calculator. Last step, I want you to explain all this. Remember, we're trying to solve. What is it that I need to solve this equation? What is it we're looking for?
The domain?
We're looking for the least common denominator now.
Okay, no, so we don't need to add anything. We don't need to combine anything. We need the answer. This is different because today now we're dealing with an equation. an equation is true or false depending on which x you put in. You put in an x that's not, if you put in one x, you'll get one answer and it won't be equals. If you put in a different x, it will equal and it'll be true. So we're trying to find the right x. Now that's different than the this problem is an expression. It's not solvable. It's just subtract this minus this. We don't solve it. We simplify it. With expressions, you can't solve them. You can only simplify them. But this is different now. This is an equation. And in this equation, we want x by itself. So
Should we first set it equal to 0 or?
solve for x. That means x by itself. Now this requires a lot of algebra that we haven't learned yet. But it doesn't matter. We don't need the algebra yet because I already know what the x answer is. What is the x answer when the left side equals the right side?
-2.
Yeah, we're done. That is the explanation of the answer. You're telling me, okay, we're solving this, so the answer that solves it is -2. And we know that because that's in the picture over here, where the two sides equal is at -2, 3, and that's at the x number, -2. So that has to be the x number that makes the left side and the right side equal, which solves this equation. And if necessary, we could check this. We could plug that in. Question mark. We want to see if 3 does equal the other side. And so if we plugged in the -2, let's just check and see, does it really work? So I'm plugging in the -2, and I'm going to check this side, which is, I'm going to work 1 plus 3 times -2 is -6. -2 minus 1 is -3. What's -6 divided by -3? 2. 1 plus 2 equals 3. And that's what it's supposed to equal. So it checks. So this really is the answer. And we didn't have to do it by algebra because we did the graphing method. So solving by graphing is pretty easy. You can get the answer to the equation if you can get a window that shows you your intersection. Now, it could get a little bit harder if we have to change the window to see the picture, but that's just a little bit of trial and error.